As you know, PLC is the primary component of controlling automated industrial processes. But how can we view field signals? Because PLC is just hardware, it cannot display signal values instantly to operators unless technical staff with a personal computer and necessary software establish a connection to the PLC and check the program status online to keep an eye on signal values. It is not a practical method for operations employees to regularly check what the PLC is doing, and that's where a human-machine interface, or HMI for short, comes into play. This technology is sometimes referred to in other terms, but HMI is the most often used abbreviation. An HMI is simply a control unit that facilitates the integration of operators into complicated industrial processes by delivering a user-friendly dashboard. As a quick tip, please subscribe to the channel and like the video. A variety of HMIs is available in an industrial setting, such as touch screens that enable users to access controls by tapping or touching the actual screen. They are convenient and allow for quick reactions, but they are costly. Screens with buttons attached, like function and arrow keys, and indicator lights. Built-in screens embedded into machines to observe and adjust their parameters in a factory. Portable handheld screens that, due to their lightweight, enable users to hold it with just one hand. They allow operators to move, for example, robotic arms while still watching, managing, and engaging with the operation in real time. Computer screens that operate a specific HMI software are mostly usable in control rooms, and mobile screens enable control engineers to check in and control processes from far away, eliminating the need for their presence on industrial sites. Whatever they look like, their goal is to enable operators to visualize operational data and regulate machinery. The hardware layouts of most actual HMIs are similar, which include the following. A screen for monitoring. It is responsible for the user's interaction with a targeted industrial process. Control panel. It consists of physical buttons with customized functions. And communication port. It is accountable for communicating HMI with other devices such as personal computers and PLCs. The software configurations of most genuine HMIs are alike, which applies in two steps. First, development. A personal computer is used to program the HMI through a special software. The HMI software allows engineers to design a graphical screen of what operators will see to monitor and operate industrial machinery. If you are interested in HMI programming, you should consider some essential design tips, such as user awareness. Consider the users who will be using it and think about operators' limited knowledge when it comes to operating industrial processes. Visibility. The system's design should sufficiently resemble the actual process to provide users with a positive interface experience. Simplicity. Avoid crowding a screen and don't use improper 2D or 3D graphics which may interrupt the user's focus on important information. And consistency. The design flow should be consistent while retaining intimate details. For example, ensure that color codes are consistent throughout the system when displaying status information. The second step that applies in the HMI software configuration is runtime. The design dashboard is downloaded to the HMI from the personal computer, and then the HMI runs the program on its screen to be visible to operators for further use. Now let us talk about HMI process control. For the HMI to provide an interface for a manufacturing line, the HMI usually needs to be connected to a programmable logic controller or PLC. Compatibility between the HMI and PLC is required, meaning they must be able to communicate with one another. So they do this in the form of an industrial network protocol. Different manufacturing vendors utilize various protocols. The most widely used protocols in the industry include Profibus, Ethernet IP, Modbus TCP, etc. The PLC will receive information from sensors mounted across the industrial processes in the manufacturing line and will start processing the collected data into logical combinations. As soon as the PLC provides real-time data directly to the HMI is used to convert complicated process variables into information in the form of a graphical way that may be used to take appropriate action. At this point, the operator can send commands through the HMI screen, and the HMI will transfer user inputs to the PLC to be processed into the logical format. Then the PLC sends translated data to the actuators to be executed over a given industrial process system. Most HMIs have the same basic and extensively utilized functionality, such as monitoring. HMI displays a graphical representation of system status and provides information on plant operations inputs and outputs to let the operators know what their process is doing. Controlling. HMI dashboard may be utilized for performing sophisticated actions, for example, running programs and starting sequences. Another example to mention here can be configuring new set points and control targets for operational parameters in the process. Alarms management. If any alarm condition happens, it should be clearly shown on the screen to let the operator know the error has occurred. It should indicate to the operator where the issue takes place and how to fix it, or the next course of action that needs to be performed by the operator to resolve the issue. Data logging. Plotting capabilities and the potential for storing data in the internal or external memory of the HMI can be used for future references, such as adjusting settings. And troubleshooting. Many HMIs may link to PLC logic and show it on the screen for maintenance staff to use in troubleshooting. Compared to constantly connecting a personal computer to HMI, it can save significant time. And finally, let us talk about the benefits of implementing HMIs, including increased visibility. Instead of walking the operator across a manufacturing line to monitor and control different parameters, he can observe the information on process performance on one convenient dashboard. Enhanced efficiency. The operator can access and use real-time data provided by the HMI to adjust relevant changes and keep an eye on manufacturing procedures to make the process more efficient. Decreased downtime. With the help of analyzing process information, the operator can identify possible failures and address them before they become problems that might cause prolonged downtime. Ensure safety. For industrial operations that use potentially dangerous materials or processes that cause injury in getting close to them, the HMI improves safety by putting more space between the operator and the machinery. Ease of use. By using HMI software, engineers can get rid of additional physical wires and buttons, which proves working with HMI will be much easier for the operator. And cost reduction. The significant financial benefits of using HMI software are paying less for equipment repair and lowering the payment for training operators to use HMI since it's an easy-to-use device. What about other features of HMIs that have not been mentioned in this video? Please share your thoughts and experiences with us and the audience in the comment section. Also, please encourage us by liking the video, subscribing to our channel, and pressing the bell icon so you can get notifications whenever we publish new out-of-the-oven videos. This way, you keep motivating us to produce more informative videos.